Now recall the formula for number of combinations of n objects taken r at a time. And here's the formula. It's given by n factorial divided by r factorial times n minus r factorial. Now, as you also may remember, the combination formula comes from the permutation formula. And if you remember, each combination generates permutations, and that relation is given by the number of permutations n comma r is the number of combinations times r factorial, and this will give you the formula C and R equals to permutation and r divided by r factorial. And this is actually good to remember because we learn how to easily get the formula for the number of permutations without memorizing anything, just thinking about the analogy or the diagram of slots. So if we can remember how to get the number of permutations, then you can easily get the number of combinations by dividing by r factorial. Now you can think of the division of by r factorial as something to take care of the repetitions or the order of the permutation. Remember that permutations, think about arranging books on a shelf again. If you have, let's say 7 books on a shelf, and if you switch 2 books and put them in a different order, right? You just swap 2 books on the shelf, then you're going to have a different permutation. That's because the order is important. Now, dividing by r factorial, you're going to take care of that requirement of order. So by dividing by r factorial, you're going to disregard the order. And so you can think of dividing by r factorial as something to disregard the order of the permutation. Let's take a look at one example. Let's say we want to find the number of combinations of 8 books taken 3 at a time. Now, what is the difference here from permutations? Combinations, you're simply grabbing 3 books out of 8, but you're not arranging those 3 books. You're simply picking those 3 books from a bag or from a box. So you don't regard any order here. So the order is not important. Now again, how do we find this? We can use the formula. Let's use the formula here and see what happens. So this would be 8 factorial divided by 3 factorial divided by n minus r. So it would be 8 minus 3. That's 5 factorial. So this is 8 times 7 times 6 times 5 factorial. 3 factorial is 3 times 2 times 1. And 5 factorial, that will cancel with that. Here I can cancel 6 with the 6 here. And this will give me 56. Okay. Now let's do this again. Now let's say we don't remember the formula. Well, again, let's use the slots because we will obtain the number of permutations first. At this point, there will be a point where you won't need to use the slots. You can simply think about the 3 objects and then multiply the 3 factors. So we have 8 books available and you're picking 3. So there's 8 possibilities for the first book, 7 for the second, and 6 for the third book. Now, that expression will give me the number of permutations. But we're finding the number of combinations. So in order to get the combinations, the number of combinations, we need to get rid of the repetition or the order of the permutation. And as I said here, dividing by r factorial will take care of that order. So we get rid of the order. So we simply divide by 3 factorial to get rid of the order. So that will give me 8 times 7 times 6 times 3 times 2 times 1. And this is 8 times 7, 56. Okay, let's do one more example. Here's 100 combination of 100 books taking 97 at a time. And again, you can do a similar idea. You're picking 97 books out of the 100. So this will be 100 times 99 times 98, and there will be 97 of these factors. So this is going to end up at 4. Now, that expression by itself gives me the number of permutations. But permutations, the order is important. In order to get rid of the order of the permutation, so we can find combinations, then we divide that by 97 factorial. Well, and then here, we can easily recall the completion of factorial. So we can do, I don't need to write the expression again. I can simply do this times 3 times 2 times 1, and then I do times 3 times 2 times 1. This will give me 100 factorial divided by 97 factorial times 3 factorial. So you can easily get the formula without remembering the formula for combination. By what we do here is simply remembering that combination comes from permutation divided by r factorial. Now, combinations, number of combinations also can be found by using this interesting property. It's called the symmetry property. C197 is actually C103. So recall, C and R is equal to C and minus R. It's called the symmetry. And this is actually very easy to prove. If you can work with the formula. From the formula here, you can actually obtain the formula here. And it's very easy. I'll leave that as an exercise that you can easily do it. So in this case, it's much easier to find the number of combinations of 3 books instead of 97. I can apply the same analogy here. So 3 books out of 100, so that will give me 100 times 99 times 98, because now it's only 3 slots. So I have only 3 factors. Again, this will give me the number of permutations of 100 objects taken 3 at a time. But I don't want number of permutations, I want number of combinations. In order to get rid of the order of permutations, then I need to divide this by 3 factorial. So notice that this is actually the same as this one. So if I complete the factorial here, if I put 97 times 96 times 95 all the way to 3 times 2 times 1, then notice that these factors that I added, that I use it here, those represent 97 factorial. So this becomes 100 factorial divided by 3 factorial times 97 factorial, which is exactly the same as here.